Okay. So anybody got any question about week week one content? Is there anything you want to ask in advance? Otherwise, I will move on to the quiz that we just did. For the first, sorry. So the first compound is the name is 2-bromo 1,2,1,3,5 triazine. If you follow the Hans-Wittmann system, and it's aromatic because there are 6 pi electrons in the ring, and all of the nitrogens are kind of basic, but it's not that basic if you compare with the normal amines. So these are much more basic than this lone pair in sp2 due to the hybridization. So if you call they are basic, then that's fine. I will give the mark, but it still have some availability on the lone pair because it's not involved in the aromatic system here. Okay. For the next compound, in this case, the nitrogen is fully basic because it is in sp3 orbital, right? So this is more like a simple amine. And the way you name this compound is 5-chloro. So it's 1, 2, 3, 4, 5. 5-chloro 4. Oh, sorry. 1, 2, 3, 4, 5. Because oxygen is the most important one. So 5-chloro 4 ethyl and 1,3,4 oxaziazolidine, or this one could be N ethyl as well. And this is non-aromatic because you don't have the pi system. And therefore, all of these heteroatoms will be sp3 hybridized. So there is no electrons in the pi system. So 0 pi electron, right? Okay. The next compound, in this case, if you stick with the common name is 1H parasol, right? But you can also use the Hans-Wittmann system, which is 1H12 diazole, and then the fluoro is at position 3, so it's 3-fluoro 1H12 diazole. By the way, I'm not 100% sure with all the naming systems, so if you have some other suggestion, please correct me if I'm wrong. But I'm not going to focus on this that much. In the exam, there won't be any naming. Just as your information. And this compound is aromatic because this nitrogen has lone pair in the p orbital. So this is sp2 hybridized. This is sp2 hybridized, but it gives only 1 electron in the aromatic system. So it's 2 and 1, 1, 1, 1. So it's 6 pi electrons and aromatic. And this nitrogen, because the lone pair is in the aromatic system, so this nitrogen is non-basic. And this nitrogen is weakly basic because it's in sp2. The lone pair is in sp2 orbital. Okay. The next compound, this one is 6-methyl. 1, 2, 3, 4, 5, 6. Because S is more important than nitrogen, has higher priority. So it's 6-methyl 1,3 asa, but for 7-membered ring is EP, and for the ring that contains for the 7 member ring is ine, so 6-methyl 1,3 triacetylene, and it's non-aromatic because if you count the number of pi electrons, if it stays in the flat system, this will be 2 1 1. Maybe I should change it. Okay, change. Okay, so 2 1 1 1 1 1 1. So in total it's 8. But if it's 8 pi electrons, it's gonna be anti-aromatic, so it doesn't want to be like that. So it will twist, or sometimes maybe the sulfur is hybridized as sp3 instead. When it's sp3, the lone pair is now not in the p orbital, so it doesn't delocalize into the system. So maybe for the optimum conjugation, it will only resonance between these 6 atoms, probably. I'm not 100% sure. So it could be like the total is 6 pi electron, but not aromatic, right? Because it's not fully in circle. Well, and I mean, these are kind of like dodgy. It's not that 100% correct, but definitely not 8 pi electrons. It could be 6 pi electrons by the conjugation of these 6 double bonds, or maybe it might twist so that none of the double bonds overlaps or something like that. I'm not 100% sure. Okay, but anyway, this nitrogen is also weakly basic because the lone pair is in sp2 orbital as well, right? Okay, any question? Last compound, this one, the naming is, I'm not 100% sure that I'm right. So it's pyrimidone, right? Pyrimidine is the six membered ring with 2 nitrogens, and pyrimidone is the one with the carbonyl group, and it's 4 because it's 1 2 3 4 for pyrimidone. But for the Hans-Wittmann system, I'm not 100% sure, but it should be 1H13 diacene to specify these 6 atoms, and then it's the 4 oxo at the carbonyl group here. Could be. I will consider your answer and see whether it makes sense or not. And the chloro at the 2 position. Okay, and this compound, if you draw it like this, it is not aromatic, because although you have all the pi systems in planar. So if you draw like this, there is a p orbital here, This nitrogen can have sp2 orbital, sp2 hybridized as well. So all of these will have 6 pi electron, 1 1 1 2 1 1 and 0 here. Okay, so it's 6 pi electron, but if you draw it like this, the electron cannot delocalize in circle because it's stuck at the carbonyl group. So the way it is partially aromatic is that it has a resonance structure. So by drawing the resonance structure, they are still the same molecule, but the real molecule is the combination of the two. Okay, the 2 characters will be combined, and depends whether, if this is more stable, then the real molecule will have more character of this molecule. If this molecule is more stable, then the real molecule will have more coefficient, and then it will have more character of this. But anyway, this one has 6 pi electron, and it can delocalize. So this is aromatic, right? This compound this resonance structure is aromatic, and this one probably not aromatic. So you will get the partial aromatic character from the other resonance structure. Okay. So it's 6 pi electron for sure. And this nitrogen is weak, is non-basic because it used the 2 electrons to delocalize into the ring, and even worse, it also delocalized into the carbonyl group. So this nitrogen behaves more like combining the pyrrole and the amide. So even like very much non-basic at all. But for this nitrogen, it's in the lone pair is in sp2, so this is weakly basic. Okay. By saying weakly basic or strongly basic, it's like the vague line that like the pKa between, let's say, pKa of 20 to 40, probably called, well, I mean, it is not definite line. It's just comparison between this and the simple amine. If you compare this with sodium hydroxide, for example, these are all weakly basic, right? Even amines are weak base. If you compare the amines with sodium hydroxide, then this is much worse, much weaker basic than sodium hydroxide. And if you compare sodium hydroxide with, for example, N-butyl lithium, then these are so-called weak base. This one is strong base. So by saying this, I'm just having a level between, you know, the non-basic at all. It won't behave as a base for sure, and then it may behave as a base in some cases with a very strong acid conditions, and also the simple amines with which usually can behave as a base but not as strong as, you know, the inorganic base. Okay, so that's the answer for the quiz. Do you have any question about this content? No? Has anyone started the lecture 2 content? Okay. Well, so that seems no one have any question. If you have any question, then feel free to leave the comments in the Blackboard system as well, okay? For your homework as well, you can, if you don't understand why this is incorrect, you might ask me, or you may say, okay, is the correct answer would be this or that. I don't want to give you the exact answer, so because I want you to try to find out what is the right answer first, okay? But I hope everyone have seen the feedback in your homework, right? I already mark and then say which one is correct, which one is incorrect. Okay, if that's so, I think this class is finished. Very quick. Well, if you don't have any question, then that's it. Hope you, any comment or question? No? Any suggestion about the lecture content? I at the moment I have a dilemma whether I should divide the lecture into, like, you know, the small videos like what I'm doing here, like 10-15 minutes video, or should I do it as a, like, you know, a 1 hour or 2 hour video? Which one do you prefer? Hello.
I think that the video that I can send last time divide into 50 minutes is okay. We can,
it's okay, like, right?
Study.
Yeah. Okay, good. So the next class, the assignment is you know, it's only paperwork. So hand in the lecture, the question as always. There is no presentation next time, but the week after there is going to be the full presentation, no paperwork. So if you want to prepare in advance, you can study the week 3 it as early so that you can prepare the assignment in advance. Okay. Nothing else. That's it. Okay. Thank you very much. See you next time. Bye.